Now we are live on YouTube also.
Okay, sir.
And 15 we will start, sir.
Yeah, exactly 10:15 we'll start.
I request all the participants to switch on your videos. So it will be better for to interact each other.
मैं अपने बच्चों के बैठने के लिए जगह तो दी नहीं।
Sarita ma'am.
Yes, sir.
Yeah, we can start.
Okay. Okay. Good morning to all. Good morning. It's a great pleasure for me to introduce our speaker today, who's going to talk to us about machine learning. This is a subject in future we should all be deeply interested because it's highly on demand and future rely on it. Our speaker has 15 plus year of experience in monitoring national and international organizations. Please welcome Mr. Saroj Kumar Gupta. It's over to you, sir.
Thank you. Thank you, Sarita ma'am. Can you hear me? It's
Yes, sir.
Hope it is audible to everybody.
Yes, sir.
Okay. Warm welcome to each individuals who has participated and going to participate in this event. This event is going to be very interactive session, and the machine learning is used for everyone, each individual who are going to research or maybe planning for research, students who are going to do the project, either it is UG project or PG project. Each and every one in all the fields of students are using right now machine learning. It is not pertains to a specific course or the area. Everyone is using, either you are in chemistry or physics or maybe biology, computer science, and many more branches. Everyone they are using, and it's today's demand. So let me share my slides, and let's go through the slides, and we'll have a hands-on training as well.
So at the bottom of screen in middle, there will be an icon with share. Yeah.
Yeah, hope is it visible, sir?
Yes.
Yeah,
visible.
it is visible, sir. Put it on full screen.
Okay, sir. Thank you. So hope it is visible to everybody. As I said, the session is going to be very interactive, so I need each and every participants to be with me. The outlines should be the first. I'll tell you about the fundamentals of machine learning.
Gupta sir, it will be great if you put it on full screen.
Yeah, it's on a full screen, sir.
So,
Okay. So the fundamental of machine learning we'll have, and then the hands-on training we'll have, and then in an afternoon session we'll have a live project, and we'll explore each and everything how you are going to design it. And trust me, the participants who will be in this session are going to design machine learning project by themselves. Either you are in computer science or electrical or in management side, whatever the branches you have, or in you are doing the research in whatever the area, you will be able to explore, you will be able to design your project using machine learning through any problem. What I should do? Yeah. What happened? Okay,
it's okay, sir. You can continue.
yeah. So let's start with the fundamental of machine learning. So the questions arise first, what is machine learning? In fact, the many of you might be wondering about the name called machine. So there is a certain called as a machine and all. No, it's not about the machine, but it's all about a program. The machine learning is a technology which is designed by the Samuel, and it's a program itself which makes our machine to learn automatically, optimize it, improve the performance, and the very beautiful things is you need not explicitly program further. It learns by itself. Say, for example, if you talk about a weather forecast, for a weather forecast, no one is programming every time, but it takes the weather conditions, humidity, temperature, and the program predict for a future. There is nothing called as a programming again and again for each and everything. So what's the definition of a machine learning? The machine learning is a technology which learns automatically from the environment, optimize the performance, and there is no need to program explicitly for each and everything. As it's a part of artificial intelligence, the artificial intelligence have broad categories like machine learning, deep learning, cloud computing, and so many categories of artificial. So we can say the machine learning is a subset of artificial intelligence itself. And it is used in every sector, as I said. Now, if we really wanted to understand how exactly it works, so there is an example. If a kid want to touch a flame, the candle, then definitely goes and trying to touch the flame. When he touches the flame, he start crying. He or she start crying. The baby start crying. Now again, when the baby want to see, to touch, that he feel that no. Before when I touched, my hand has burned. So now starting thinking, okay, previously I touched, so now I should not touch further. So what happens actually? The kid brain has trained. The kid brain has trained. And this training is what exactly works in a machine learning also. The human does the same way as the machine learning does. We teach our kids A, B, C, D, and he or she remembers the pattern the same way machine learning does. The machine learning learns from its past experiences, what we have trained. First, we need to give a training as we give a training to a kid. And then how a human act, the same way machine learning agent also act. The agent means here the expert system. Say for another example, you can say our students give exams. So how they give exams? First, they prepare themselves. Then they go for exams. And while writing, they recall all the answers and writing. In the same way, machine learning also does. Machine learning also does in the same way. Now, if you talk about the traditional programming as the Java technology and other what we are using, how our things work, we give a data input as an input, and there is a program, and we give to the computer, and we are expecting output. Say, for example, we write a binary search program. We give certain input to the program, to the machine, and what we are expecting? We are expecting that certain things has to be searched. We search it. Whereas in machine learning, it doesn't happen like this. Machine learning doesn't happen like this. Then how it happens? A data and output has to be given to the computer, to the agent, and then it generates a program. So see the beauty of this. The beauty of this is what? If you compare both traditional programming and the machine learning, the traditional programming, the data and program has to be inputted to the computer and we receive output. Whereas in machine learning, we give data, we give output also, and then it generates a program. That programs does the magic. That programs does the magic. And trust, it's a very easy program and modules. When we'll have interaction with the coding, you'll feel that, wow, it's a very easy coding and you'll be able to design it. Each and everyone will be able to design it. First, the basics, it's a ABCD about your machine learning. So what exactly, let's understand once again, If we talk about the binary search as example I given, in this we give the data as an input to the program, to our computer, and it gives output to you. Whereas machine learning doesn't do like this. We are giving data, what we call as a data sets. We are giving output to the computer and it generates the program, not output. It doesn't give an output where it gives a program. That program is called as a model. That program is called as a model. Now, we'll have a three kind of machine learning, specifically broadly categorized into three. There are different learnings, but it's a broadly three categories we have. One is supervised learning, another is unsupervised, third is reinforced learning. Now, the supervised learning further classify into two, regression and classification. And the regression algorithms, there are various regression algorithms which does the magic for a model generation. Linear regression, we have decision tree, random forest, k-mean clustering, support vector machine, Gaussian, and so many. These are the few algorithms name I have just written down, but there are many more regression algorithms, many more classification algorithms. And in unsupervised learning, clustering and association are two categories of unsupervised, where the two or three examples I have given for the algorithms. But it's not limited to, there are many algorithms which is going to be used when as per your requirement, because your requirement is what it depends on that you are going to use. You are going to use k-mean clustering, or you may going to use neural network clustering or KNN model. What you are going to use, that it depends. Next, reinforcement learning. There are algorithms. There are Q learnings, start, action, reward, deep Q neural networks. So these are a few algorithms which we are going to use for our, excuse me, I'll put it my laptop to the power mode. Okay, sorry. So what is actually supervised learning? The supervised learning name itself depicts there are a certain supervisor like a teacher. The teacher supervises the students, and while supervising the students, whatever the student does, whatever the action the students does, the teacher is supervising. If it does in a correct way, or if it is performing in a correct way, then we not have any objection. When he behaves erratically, we just warn them that no, you don't do it, or just do it. So what does it mean? It means that a supervisor. So here also, the data sets or the database which we use is a leveled data. In the supervised learning, the data will be in level data, and all the leveled data has its own name. Like if you see in this supervised learning, how this works actually, There are a hexagon, triangle, and square, which is going to be passed through. This data is passed through a algorithms for a model, and we are going to train them first. First, we are going to train them how the kid has got trained while touching the flame. In the same way, here also a kid, the algorithms is going to be trained based on the input data, and the input data is a hexagon, triangle, and square. And what does it mean by level here? Just we should understand. The level means there is a diagram called as a hexagon, and the name of that is given below is called as a level. The triangle is a shape, and the name of that below it's given is a triangle. So that is the level. If you have an apple and the below, if it is written is an apple, that is called as a level. So when the machine get trained based on a given algorithms, based on a given input, then that model is ready to test. That model is ready to test what it has given in this diagram. And now if we give certain called as a square or a
Gupta sir,
triangle.
just a minute.
Yes.
Sorry to interrupt you. Are you using slides?
Yeah, I'm using slides,
But
sir.
we are not able to see. Actually, on screen we are able to see first slide only.
Is
Now
it
it's okay. Now okay, sir.
okay? Are you seeing this?
Yeah, now we can see your slide how supervised learning works.
Yeah. How
Yeah.
supervise, and can you see it's changing? Are you seeing that
Change.
it's changing
No,
now, sir?
no, sir.
Then what happened? Now you can see. Now you are seeing that.
Now it's changing, sir.
Okay. While maximizing, it's not getting done. Okay.
No issues. You minimize normal mode. You can use.
Okay. Okay. No problem. Fine.
Now
So
it's
I
working,
think.
sir. Now
Okay.
it's working.
So I think the many of you have not seen this. I think. Right.
Yeah.
Okay. So there are some technical problem. So again, let me go to this slide. So this was the first slide. Hope you have seen this, the fundamental. I said about a definition. I'll start with the example how the machine learning works. Say for an example, we'll understand with the example. If a kid want to touch flame, he has a curiosity to touch that, and again he trying to touch. Obviously, once upon a time he touch it. When he touch, he is crying now. And again, second day or third day, might he'll be thinking whether I should touch or not. So what happens to that? He doesn't have a curiosity to touch now. Why? What's the reason? Because he got a pain. His hand has burned. Now he'll be thinking from the past experience. Past experience was what? His hand was burned. Now he'll think again and again whether I should touch or not. So what happens actually? His brain has got training that when I touch, my hand will burn and I'll cry. So now he or she, the kid will not touch further. The same way machine learning also does. It gets the training from the past experiences and predict the today's and the futures. Again, I'll repeat it. The machine learning technology does in a same fashion. It trained from the past experiences and predict today as well as the future. So that is what the agent on machine learning does. Same way the human also does. How the human does? We have remembered a lot of questions we know a lot of things, and whenever is required to recall, we recall. Suppose if someone keep apple in front of you, then you'll recognize, oh, it's apple. If suppose if someone keep in front of you one different fruits which you have not seen, then you will wonder, oh, what kind of fruits it is, because you have not trained your brain on that. You have not trained, you have not seen that fruit before. If it is apple, you can say, oh, I know it, it's an apple. If someone keep in front of you avocado, then you'll not know that, oh, it's avocado, because you have not seen. So the fruits which you have seen, you can say that it's that name. But if you have not seen, you cannot say the name. It is what? It's previous experiences, what the machine learning does in a same fashion, sir. If you talk about other technology apart from machine learning, the machine learning works in different way compared to other technology. We are giving data. The data can be of anything, either biological data or in molecular biology's data or molecules data, or you can say your hotels data, any kind of whatever the project you are using, definitely you'll have a data sets. That data sets and program you are giving to the computer to generate output. That is a traditional programming or technology. Whereas in machine learning, as I said that machine learning going to predict today's as well as the future things, or based on the training, the previous experiences. So same way, if you compare the both, the traditional as well as the machine learning, how it works. So we are giving data and output to the computer, and it generates a program. It generates a program that we call it as a model. And that model further going to be used to train our input and predicting the future result. There are three broadly categorized the machine learning. One is the supervised learning, second is unsupervised, and the reinforcement learning. There are many more learnings, but these are the three prominent machine learning categories. The supervised learning means there is something called as a supervisor, and that supervisor is supervising that my program is working very correctly or not. Whereas in unsupervised, there is nothing called as a supervisor. So the supervisor is what? Supervisor, something like a teacher. And to whom we are supervising? We are supervising to a students. So a students and teacher is working. Good example for the supervised learning. We are in a class and we supervise our students, whether that is working correctly or not. In the same way, there are various algorithms which you are going to use, and few are the prominent one, popular one, the linear regression. You have decision tree, KNN, you have SVM classifier, we have. Supervised learning is divided into two categories, regression and classification algorithms. In regression algorithm, suppose you want your output in terms of certain values. So you are going to use regression algorithm. I'll repeat it. If you want your output should be in certain data, certain values, then you are going to use regression algorithm. And when you want your output should be in terms of yes, no, categorical data if you want, then you are going to use classification algorithm. Okay, so you are going to use categorical. So what does it mean by categorical and value? See, we'll understand with an example. If you want humidity of 2 days in your mobile, just to click on your mobile phone and while seeing the values. So what is that? You are seeing that the humidity is 4 or 5 or 6, temperature is 9 degrees C or certain degree K. So what is that? That is a value. That is about regression. The regression algorithms give you a value as a result. Whereas classification, it gives the value in terms of yes, no, 0, 1, what we call as a categorical values. Suppose if a person has a diabetic, so it will be in terms of 0 or 1. 0 means a person have no diabetic, and 1 means a person is having a diabetic. If a person have a cancer, you may ask questions to the machine learning whether whether I'm having a cancer. So the machine learning algorithm will give you a value in terms of yes, no, and
Gupta sir, you are muted. Unmute yourself.
okay. So now if you talk about a clustering, so what is unsupervised learning? The unsupervised learning is something like there is no supervisor for this. It learns through its, as per the time passes, it learns and predict the shapes or predicts the future. Reinforcement learning is working based on the action and reward. Say we does some work, and for that work we are getting the salary. So this is what we called as the action. We does the action and we got a result of that as a reward. So this is the 3 categories of machine learning. Next, how the supervised learning works. Actually, in here, there is a model which we have generated while doing our project. Will know what is that model here. So this is the data sets. Data sets are given in a forms of certain shapes. So here is a hexagon, triangle, and square. And this is a leveled data. In supervised learning, all the data sets are given in a leveled data. Level, what's mean by leveled? Leveled means certain name of that, certain values of that. So if it is a hexagon shape, the below name is given hexagon. If it is a triangle, the name is given below triangle. If it is a square, below it has given as a square. Now, the machine learning takes the input and it trains, it gets trained. And while getting trained, a model is generated. As I said, here, a data has been given as well as output is given. So what is the data? Data as a shape, and the output as that is a hexagon or a triangle or a square, that is as an output. And this computer, that computer that programs generates another programs which is a very smart programs in machine learning. So this now it's ready to predict. Now we'll give a test data. Test data means we are going to give certain shapes to that program, whether it is predicting correctly or not. And obviously, when we give without any leveled, now when we test, we are not giving any leveled to that. We are just giving input as a square and a triangle, and this predictive model, this prediction model, predict that this is a square and this is a triangle. It predicts automatically. We need not give any clue to the model that it is what shape. How it has given that this is a square and triangle? From the past experiences, because the machine learning has, the program has first trained it based on the leveled data, and now this machine is tested and the result is shown here that this is a square and triangle. In the same fashion, the unsupervised learning also works. Here we are giving a cluster of shapes or cluster of inputs without leveled. So here some of the pets are given. In this we have cat, dogs, and certain different kind of pets, but the name of that pets are not given. What does it mean? It means that there is no level for that. So how the machine works, despite of level, there is no level. The machine learns from its features. Just it extracts the features from this. It checks that, okay, similar items, the mouth is like this, shapes are like this, so it is called as a dog. If it is a cat, then if ears is like this, eyes like this, nose like this, then it comes under categories of cat. So like that the machine learns, and it takes certain times, and that again the training given to the algorithm, and now it is ready to predict. So here there is no level, and while giving the input to the model, there is an output called as if you see, the two pets are comes under dog categories and two pets are under the rat cat category. So this is the two categories, what we call as a clustering algorithms. What we here we have seen is in a clustering algorithms. Okay. So you may use k-mean or hierarchical cluster, or so many algorithms are there you can use for clustering. Okay. Next, how the reinforcement learning works. As I said, the agent is trained and that agent does the action. How the action is done? He does the action into the environment. And so this is about that categories. Now it's a time for hands-on training. So hope you'll be you just I have given you a very short hello.
Yes, sir.
सर ये साइन आउट क्यों हो जा रहा है बार बार? Why it's getting sign out?
Maybe there was some glitch in network.
Okay, So fine, it's a time for hands-on training. Can you hear me, sir? Is it audible to me? Is it
Yeah,
audible to
we
you?
can hear, sir. Yeah. Please continue, sir. We
Hello.
can hear you. Sir, you are audible. Please continue.
Fine, thank you. So the hands-on training will be there now. So what we'll do in hands-on training, first the machine learning life cycle we'll see, and through this life cycle we are going to learn how a project is built. You have seen the SDLC, the software development life cycle. The software development life cycle and the machine learning life cycle are quite different. The machine learning, any projects are going to work based on the data sets. Keep it in mind, your machine learning algorithms works only based on the data sets. So how we can get the data sets? The data sets will be taken from the environment, obviously. It depends on your project, what kind of project you are going to design. If you are designing some projects for hotels, you are going to get the data sets from the hotels, different hotels. If it is for medical, you are going to take the data sets from the medical. Here the data sets means a database. We in machine learning we call it as a data sets. In other projects like Java projects and all, we call it as a database. Here we call it as a data sets, not database. So that's why I'm calling all the time data sets. So hope it should be very much clear. So you are going to take the data sets. The data sets is the huge results of the particular events. It will be again in a two categories. It may be in a categorical output or it may be a value. So certain numerical values like 1, 2, 3, 4, 5, or maybe categorical output like 0, 1, or it may be something like yes, no, true, false. So this is the categorical output. So the your data will be in two fashion, either in numerical value or in categorical fashion. So how the machine learning life cycle works? So first we have to gather the data sets. So the data sets, as I said, you are going to gather from the environment, from the organization. Weather forecast takes the data sets from the environment. For hotels, you are going to take the data sets from the hotels. For cancer, you are going to take the data sets from the labs, patholabs, or there are so many hospitals who provides the data sets. If it is for a chemistry or for physics, you have so many data sets to predict. You can take the data sets from the lab. So likewise, you can collect the data sets. So the data are of a two type. The first is a primary data and the second is a secondary data. There are two kind of data. If you are a researcher, then you are going to use the primary data. What is meant by primary data? A data which is used for your purpose and collected by you. You are going to collect through the telephonic interview or through the questionnaire. You are going to directly collect those data, gather those data based on your requirement, because it is your research. You are going to prepare a questionnaire. Based on the questionnaire, you are getting the result. So that is called as a primary data. That is the original data. What is meant by secondary data? Secondary data is one which is already available onto some website, and it is a used data. It is used by someone, and we are going to use for our reference. As I'm going to use in this project the secondary data, and there are various websites through on which you can download secondary data, and it's a free of cost. Everything I'm going to tell you. So you are going to gather the data. So two broadly categories we have. Then we are going to prepare those data for use. So in the preparation, we'll have cleaning the data. We have something missing values we'll have, and some errors we'll have. So it is not always necessary that the data sets which we have downloaded is working very fine, or there is no error, it's error free. It's not necessary. There may be some errors, there may be some missing values. So all those missing values or errors we have to rectify, we have to wrangling, munging we have to do. Then our data is ready to use it. Directly to download and use the data is not a good practice. First, we have to prepare those data, clean that data, analyze those data. Then we have to predict for a future or today's event. So this is a 7 life cycle it has to pass through. Then our model is going to be ready for use. So first gathering the data, then preparing, and then wrangling. Wrangling means the cleaning the data. Any outliers or errors has to be removed. Say, for example, if I want to collect temperature of a person, if a person has given his body temperature as a 0, definitely the temperature 0 is a value, right? But any body doesn't have a temperature called as a 0. If it is a normal temperature also, the body may have some 97 or 96. So this is what? This is something called as errors in the data sets. These errors has to be rectified. Okay. And then analysis the data, training model, then test the model, and then we are going to deploy it. These 7 life cycles we are going to see in our project. How you can gather data, how you can gather data. You can gather data using Kaggle. Kaggle is a free software, a free website. It's open for everybody. You can download it, and it's free for everyone. I especially use Kaggle for secondary data. UCI machine learning repository. You have datasets via AWS. It's from Amazon. Google datasets, search engine are there, and Microsoft also have its own datasets. There are many more also to gather secondary datasets, and all those secondary datasets are again has to be prepared for your use. You are not going to use directly. So first, getting your data set in a data pre-processing, then importing your libraries, all those things I'll be telling you in programs. So I think let us start first. So before starting, I would like to tell you one thing. We are going to I'm going to share you about a software, which software is a good one for everyone, and it is a user friendly. You may use Anaconda software, and your system configuration, at least it should be i3 processor, 4 GB RAM, and 512 if it works with a hard disk. If you have more, it's good, but it works. So this is the hardware configuration, and Anaconda, because it's a heavy software, you can use it. Apart from Anaconda, you may use different softwares. You may use VS Code also, but especially I prefer Anaconda. It's a very good software. And in Anaconda, there is another notebook for Python called as a Jupyter notebook, and I'm going to interact with Jupyter Notebook itself. Now, the Jupyter Notebook, I'm going to open it, and then I'll tell you how you are going to interact and how you are going to design it. First, we'll understand the ABCD of Anaconda. So you can start Anaconda first. So let me start it, Anaconda. Anaconda Navigator. Okay, so this is the Anaconda Navigator. In this navigator, you can see the Jupyter Lab notebook, Jupyter Notebook, Spider. Then you have Glovis, Orange 3, RStudio, VS Code. These all are a platform where you can program it. Especially, I'm using Jupyter Notebook. It is very interactive for everyone, and it is very easy to understand. Sir, I want confirmation whether it is visible to you or not, sir.
Yeah, we can see, sir, it is visible.
Okay, fine. Thank you, sir. So this is the navigator we are going to use. So first of all, we are going to learn ABCD about this Jupyter Notebook. I launched this one. There are two ways to open in your search. Just you can write it Jupyter Notebook, or you can launch your Anaconda Navigator, and then further you launch here. Here is an option called as a launch. And if you click, a Jupyter Notebook will open in a short while. Okay, so this is how the interface looks like. So I'll tell you ABCD about this one first, and then we'll start our project. Okay. So if you observe it here, here is a file. So file means you have your file folders. If you are writing a project, obviously you are writing in a file and you are keeping into folder. So this is a root node. This is called as a root. This is a root one. Root folder. How you can know it's in root folder? If you click on this place here, you can find that, okay, the Jupyter Notebook in root folder. And your folder can be pasted here, and inside your folder, you can say, if I'll open one desktop here, if I open desktop, say we are in desktop folder, or you can say in desktop directory, and inside desktop directory, so many files are there. So likewise, you may create your folder, and then you can create your file. Okay. And if you wanted to go back again, just you click here, you'll go to root directory. So in root directory, you can keep it your folder, or in you can create your own folder. So it depends on you. where you are keeping your folder. So now, if you download your data sets, then how we can upload it onto root? There is an option called as a upload. If you click here and you have a data sets already downloaded, and the data sets should be in CSV file. It should not be in other format. CSV means it's a comma separated values. If you double click on the files, you can see that the comma separated values, how it looks like. The file exactly looks like Excel file. The file exactly looks like Excel, but it's not an Excel file, but it's a CSV file. So I'll click on this one and upload your data sets which you have downloaded from the Kaggle and say open. And here is an upload option. If you upload it, because already I have uploaded here, so I don't want to replace it or overwrite. I can say just overwrite. And if you go down, you can see that here the diabetic.csv files are there. How the CSV stands for comma separated value, or it supports TSV. TSV means tab separated value, or CSV. It doesn't support any other format. The machine learning projects does not support any other format apart from CSV and TSV, like PDF or like any doc format. It doesn't support. If you double click on these data sets, then you can see here all the values are separated through the commas. So that's why we call it as a comma separated value. That's why we call it as a comma separated value, right? So okay. So okay, now how you are going to create a new file where you are going to type your program. So here is an option, right side corner. If you see new option, if you click on the new option, you can see a Python 3, because we are using machine learning using Python. Machine learning using Python. So this Jupyter Notes is meant for Python. And just after Python, if you observe, there is a 3. So 3 is a version of that. 3 is a version of that. If you click here, this is what the interface looks like, and where we are going to write our code. We'll learn the ABCD about that. Whenever we write, we writing the comment of each and every program, and then we proceed. So I'll tell you how you are going to write a comment into your, and how you are going to save it. So I'll tell you one thing, how you can save this file. So here is an option called as untitled. You click on this, and this project is just for a test. So I'll write here for test, TEST, and I'll say rename. So look here, your file has been saved, and when you wanted to check it, just to check it here, somewhere you can see in the root directory, there is a test.ipynb. IPython notebook. IPython notebook is a extension, like we are writing a C program, C++. C program has a .c extension, C++ has a CPP. Likewise, Jupyter has IPynb. IPynb stands for IPython notebook. So we are going again here. So we have saved this file. Now right side corner, you can see Python 3 is given. And as I said, that we are using the Jupyter notebook is blend with the Python. How I can know that it's using Python? If you see right side corner here, there is a symbol of a Python. You can find it. So that is why we say that it's. And one more thing, Python 3 is written here. So that's why we call it as the Jupyter notebook is supporting a Python. Just it's a blind information we should know if we wanted to know whether it supports Python or what. But okay, so we'll go to file. As how in a documents we have certain almost similar things, you can find it here, whereas in edit you are going to use some different things. This one is called as a cell. It's a single cell. You can write it your project. You can code. You can start your code here, and if you wanted to add your cell, you can click on plus. It will be added. If you wanted to delete a cell, you can just cut it here. Your cell will be deleted. If you want to save it, as I wanted to say you, it is auto saved. You need not save again and again like other programming language. While writing a program, it saves automatically. You need not save again and again. And in a view, we are going to toggle the header and footer. Just I'll click it. See, the header has gone out. Now again, if you click, the header has come out. Likewise, the footer, these options, the cut paste, all has gone. Now again, if you see the save, cut, everything has appeared here. In insert, we insert the cell above or below by clicking here. This is a cell information while running, while execution. We can click it. If I want to run single cell, we can click here single cell. Or if you want to run so many cells, we can click on the run all cells, right? Here is a kernels. As Jupyter notebook runs the kernels where all the programs are internally built and running. And this is a widgets for GUI, graphical user interface. This is used. So now let us learn few more things about. Suppose if I write here something in a Python print, and if I write here as a hello, and I wanted to run it. So there is a two ways to run this program. This is a single line of program. If I wanted to run, you can click it here as a run, or there is another option called as a control plus enter. Control plus enter, while you click it, while you press, okay, there is an error. The error is because we have written this into capital letter, so we should not use capital letter. Now you can print it hello. So this is the output. You can find it below. This is the output. Now, as I said, while clicking, if I delete this cell, say I have deleted now, and while clicking control plus enter, you cannot find a different cell below of this. Whereas if you click shift plus enter, while I click control plus enter, there is no cell generation. Whereas if I click shift plus enter, a cell will be generated below for our reference. So this is what the difference between the control plus shift and control plus enter and shift plus enter. So if you wanted to save it, just you save it. If you want to add it, just you can add it here. You can click here. If you want to cut it, just you can see all the cells are deleted. And this is for copy. If you want to copy this one, say I have copied this one and I have added. And if you wanted to just paste it, just you can paste it here. See, the cell is pasted. If you want to delete the paste one, again you can delete it. If you want to go up or down, just it is, see, this is to change the position while running without our, if you wanted to run without shortcut keys, so here is an option called as a run. If you use it, it runs our code. So this is what, now we'll have how the comment is written, why the comment is required, because uh, our code has to be understood, our project has to be understood by the other person. So we need a comment. So the comment is written, suppose I'm writing here as a comment. So this is a webinar in machine learning. Okay, so there is a two options how you can do. You write it here, shift and hash. So shift and hash, when you use, it has been commented. It is not going to execute it. If you click shift plus enter, it is not going to execute because it's a comment. The interpreter is not going to interpret this line because it has been hashed. And there is a few more mode. If you look here on these menus, there is a code, markdown, row, and the headings. If you want to use as a headings, just if you click on as a headings, it will be in a bigger size, right? If you execute it, it looks like this. This is a webinar in machine learning. So how this will be commented, and it is and it looks good because it's your heading, and any person can see that what your below code is all about. So this is a small introduction how our uh, 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 the interface works. In afternoon session, we are going to start with a project, and this project will be on a same Jupyter notebook. So let us learn some more things, some more shortcuts. So if you any commands which you are running here, it will be run on a command mode, and the command mode will be activated using skip button. If you use the skip button, the command mode will be activated. It will not be visible to you anymore anywhere that it has been active, but still it has been active. Suppose, say for example, if I click H, nothing is coming. Just somewhere it is written as the H. But if I press skip and then I click H, look here, the all the shortcut keys has come here. You can refer it. So many shortcut keys are there. It's for your reference. So you can see either you can press H, or you can go to help, and you can see keyboard shortcuts. You can see here so many shortcuts are there. It saves your time. And there are palettes. You can use P. If you click P, there are so many palettes, and these palettes are for a heading. So if you are giving something like heading here, so if you wanted to change your size, suppose if I want, again, if I copy this one and if I paste it here, and say this is a single line. This is a single line. If I want to use shortcut keys to hash this, so I'll use control and backward slash. So it has been selected, right? It has been commented. If I have so many lines like this, if I have so many lines like this, if I enter here, again I paste it, again I paste it, and so many lines I have. So how I can comment it? Just you select it all and press control and forward slash together. So it will be selected all together. And while selected, I want that the font size has to be changed. I don't want it should be in a same font. So I'll press skip button and then P, and I'll change it. The headings called as a 4. So see, if I execute it, you can see the first line, you can see the font size has been changed. So how it has changed? I press the skip button and then P, and from here you can change the cell heading 1, 2, 3, 4. These are the fonts. 6 fonts are given here. You can change it, whatever the fonts you select, you can get in that way. So this is how it works. Next, if we have something like 2 plus 3, you can see, you can find your output. If you say some multiplication, and this is a very easy, you need not write any program, so many lines of code for doing a hard program. If you write a very few lines of code, but it does a magic for you. So that is what the Python is all about. And we are going to use the same thing in a project. So we have half an hour time again, and 12 o'clock we'll have a lunch break. Then 1 o'clock we'll come back. So meanwhile, I would like to start our project. So to save our time, because we have time, um, I'll go to root directory, and I have taken a project. Already I have typed the code for time saving. So here is I said how to write a comment. The comment is here is a machine learning project, and I'm using diabetic prediction. I have downloaded it, as I said how to download and paste it into this root directory. Already I said here is an option called as a upload, and this is a data sets which you have saved in your somewhere in folder in your computer, and say open, and then you upload these data sets, right? So this is how you are going to upload your data sets. If you have uploaded already, just to cancel it. Now we are going to Jupyter editor. So this is a comment which I have written here, and in my in machine learning life cycle, I said we are going to first getting the data. So I'm getting the data from the Kaggle website for a diabetic prediction, and then what is the second, it's about libraries. What is all about the libraries? So directly, if you know, then fine. If not, then we'll understand in an easy way. We know the C programming, and we are using a header file. What for we are using it? Because the something is predefined into that. Say printf, scanf, all the formats are predefined. The structure and or the syntax are predefined into the header files. In the same way, here the libraries are a collection of models, collection of modules. So many modules are there into that, and each and every modules has a so many classes and files and folders, and all those classes are predefined, and we are using those libraries into our programs. So there are so many libraries, and we are going to learn few libraries. And the first one is a Panda library. The Panda library is a very useful library for data analysis, because your data is correct or not, how the data looks like, what are things to be clean. All these things are predefined in Pandas library. NumPy stands for numerical Python, and it is if you have a scientific data, something like a multi-dimensional data, or you have large, huge data. Yeah, and also I'd like to share you Python Panda is supports millions of data in a fraction of minute. It can manipulate, it can analyze the data, it can clean the data. Whereas if you use other softwares, it takes a very few minutes. But this one, uh, machine learning, in fraction of minute, it will give you the result. NumPy is another, and Matplotlib. Matplotlib is for any kind of something like if you want to plot your diagrams like a pie chart, histogram, scatter plot, graphs, if you wanted to design, you can use Matplotlib. Mat is Mat is Matplotlib is used. It's a library for plotting. Okay. Now the Skitlearn is another library. Skitlearn is another library like and the name called as a sklearn. We are using Skitlearn as a sklearn, and it supports various supervised and unsupervised learning algorithms. We are using algorithms, as I said in a slides. So many algorithms was there. Those algorithms are predefined under sklearn, and what the object called as a sklearn will use it. Matplotlib is another library, NumPy. So there are so many libraries further, but these few libraries are a very prominent. Need not write so many libraries. Whatever the projects you are doing, based on that you can use the libraries. Need not use like our C programming. If we are using getch and clear screen, we are using conio.h. If we are not using, then we are not using getch or clear screen, then we need not write hash include conio.h. So likewise, similar way here also, if you're using your some numerical analysis data, huge data, or a multidimensional data, then you use NumPy. If you're not, don't use it. So let's start. As I said, you have downloaded and uploaded your data sets here, and I shown you how it is called as why it is called as a comma separated value. .csv stands for comma separated value. And when I double click, I shown you that how all the values are separated using commas. So while importing our data sets, how to import the data set? There is one object called as a read underscore CSV. And before that, we need to import a pandas library. So how to import a panda library? We are just using import. I'll maximize the screen. Hope it is visible now. So import. Can you confirm me, please? My screen is visible.
Yeah, it is visible, sir.
Okay. So we can use the import pandas as a PD. Here the PD is an object. Here the PD is an object. It's something like a variable. You may use any variable, but the pandas is fixed. You need not change in this because it's an object. It's a library, and that library is imported by using the object called as import. And to run, just you can click on a same cell and just press it, control enter. If you say control enter, it executes, right? If there is a error, it shows you error. If there is no, then it goes to the second cell, right? So this is the second cell, how we can import a data set. We'll always look for our data sets name, just to see that what is the name of the data sets. So the name of the data sets is DIABETES. This name we should remember, and the same data sets name we should write it inside this string quotes. And there is an object called as read underscore CSV. This is an object which reads your data sets. When you execute it, you can see your all the data values, whatever the values you have in that, it is visible to you. Look here. So this data is not a categorical data, it is a values data. So what are the instances are there in this? The instances are like you have this is for this data sets is for ladies who are diabetic. Now the instances like something like variables. Instances means variables, and this is the index 0, 1, 2, 3, 4. This is the index, and this is the pregnancies. The how many times the pregnancies a ladies has a pregnant, and this is a glucose level, blood pressure, and skin thickness, insulin, whether the person is taking insulin and how much quantity it is taking, what's the BMI. BMI stands for body mass indexing. Diabetic pedigree functions is another instances. What's the age of a person, and what's the outcomes. If you look to this data sets, this is I said this is called as a data sets. If you look these data sets, these data sets are having a values. Okay. Whereas if you see the outcomes, the outcomes are in forms of 0 and 1. You can see here in your in this screen, 0 and 1 are the values, and this 0 and 1 are the categorical values. Whereas the others, you can see 6, 148, 72, it's a values. So there are two kind of data, as I said. The one is categorical values and one is a numerical values. So it will this data sets are blended with the two. It's a numerical value as well as the categorical value. Okay. So this is how you can read your data sets. Read underscore CSV, and in string quotes you can use diabetic. Python supports a single quotes also. If I write here as a single quotes, that also supports, and it executes. Instead of double quotes, if you write single quotes, even though it executes, see it executes. Okay. If so, you may use single quotes or double quotes, doesn't matter. This is how you can see your data sets. Whereas if you see while clicking here, you can not visible like that. If you see your values, it looks like this, right? It looks like this. Whereas if you execute here, the data sets looks like this. That is what I said. The machine learning supports, the Python supports CSV file here, and how your data sets looks. So these data sets are going to be analyzed. It is very important to understand. If you don't analyze your data sets, then somewhere you may have a missing value, somewhere wrong data. Suppose, say for example, I'll show you what is the wrong data in this. Suppose skin thickness. If you see here, the 1, 2, 3, 4, fourth instances, you see fourth instances. In a fourth instances, and third rows. In third rows, skin thickness, you see it's a 0. Is it possible to have a 0 skin thickness for any person? No, it's not possible. Definitely there is a thickness in our skin. So how it has written 0? It's a wrong data. So that data has to be analyzed. That data has to be clean. That data has to be removed from our data sets. Okay. So now this is how you can see your data. You can check it below how many rows are there and how many columns are there. So 768 rows are there. It means 768 patients, diabetic patients data are being collected and being analyzed. And how many columns are there? The 9 columns are there. You can count it here. The one is pregnancy, second glucose, third blood pressure. Likewise, we have total 9, 1, 2, 3, 4, 5, 6, 7, 8, and outcomes are ninth one. Okay, so 9 columns and 768 rows. As it has started from 0, so at end you can see it is 767% data are there. Okay. Okay, next, one more thing we should know, what is called as something called as a new terminology called as a independent variable and dependent variable. So the outcomes, something called as an output, means if a person has 6 time pregnancies, if a glucose level is 160, 148, blood pressure is 72, skin thickness is 75, insulin is 0, BMI is this one, pedigree function is this one, age is 50, then the person may have a diabetic. So that is what it depicts. So 1 depicts what? A person has a diabetic. And 0 depicts what? 0 depicts person has no diabetic, right? Even though he is taking insulin, but he doesn't have, look here, insulin is not taking, and if you see blood pressure is 66, it's a low blood pressure. Glucose level is 85, he has no diabetic, and one predicts it's a diabetic. So there is a 2 variables, as I say, one is a dependent variable and another is an independent variable. Each and every data sets, when you download, just to check it whether the outcomes are there or not. Outcomes means the output. After having these many data sets, a person has a diabetic or not. If it is 1, yes, a person has a diabetic. If it is 0, person doesn't have a diabetic, right? So that is what we are going to train our model by using these data sets. And when we are giving data sets, computer automatically predicts that a person has diabetic or not. We need not give outcomes. First, we should train the data sets, and based on the training, model will generate a person has a diabetic or not. So what is called as a independent variable and what is called as a dependent variable, we should know. Whenever you download any data sets from the Kaggle or from the any website, either it is a secondary or it is a primary data sets, when you are preparing, when you are a research scholar, you can prepare a questionnaire and give to the masses, give to the people. They will fill it their data sets and they will provide it. But don't forget to write the result, whether a person has a diabetic or not, person has a cancer or not, person has want to see movie or not. Suppose if you want movie recommendation system, if you want to prepare software for movie recommendation, so person want to see movie or not, that outcomes also you should collect from the person, right? Along with their interest, what kind of movie they want to see and whether want to see movie or not. So that is called as an outcome. So in each and every data sets, my mean to say, check it out, the outcome must be there, because the training you are going to give to the algorithms or a model based on the outcomes itself. And outcomes called as a dependent variable. Sorry, independent variable. Outcomes is an independent variable and and the pregnancies, glucose, blood pressure are called as a dependent variable. So all these are called as a dependent variable, and outcomes are called as a independent variable, right? So this is the two categories where the data sets lies. Now we are going to analyze our data sets. There are 768 datas, and we don't know exactly that how the data looks like, what are the informations are given. So we'll use an object called as a head, df.head. What is here df? I wanted to say you, df is any variable. Df stands for a data frame, for an instance, because Python has a you can say data structure. Three data structure has. The one is a series data structure. Second is a multidimensional, which we call it as a data frame, and the third is panels. So three data sets, three data structures are there in a data frame. The series are a single dimensional, data frames are multidimensional, and the panels are used for again a multi-dimensional heterogeneous data. Even the data frames are also heterogeneous data. Heterogeneous is something called as a different kind of values you can have. And like if you see, I'm using data frame. In this, there is a values also, and there is a one and zeros also. So it is called as a heterogeneous data. Okay, because in this categorical data are also there and numerical data are also there. That's why we call it as a category. We call it as a data frames, because the data frames are heterogeneous in nature and it is two-dimensional. Okay, so I wanted to read. I wanted to read only 5 rows of the data. Just we'll use it head and the close bracket and open bracket and close bracket. If you execute it, df is not defined. Df is not defined because here we have to execute it as a panda. We have to okay. So now if you see head, what the head does, head, it prints you only the 5 lines of code. Only 5 lines of code it will print for you. What for we have done it? Just for a data analysis, just to check it, our data in a 0 to 4, how the pregnancies looks like, how the data are gathered, what are the glucose levels, what are the blood pressure, skin thickness, and this insulin. You can see 0, 0, 0 insulins are there. 0 insulins, but a person has a diabetic. BMI, you can check it. Just to check the data sets, just to view the data sets, we are using head. If you wanted to see the last 5 lines, just you can use it tail, and you can view the last 5 lines of code. If you want in between, just you edit one cell here, and just you can write here df, because we have assigned here this data sets into df variable, and this df variable we have printed. Now the data sets are in df also. So now what I'm going to do, I want my data sets from 30 to 40, in between 30 to 40. So list can be denoted in square bracket in Python. So df square bracket starts, we have given 30 and colon and 40. If we execute it here, we have got the values from 30 to 39. Here the values which is written at a destination will be skipped. So here is a 39, up to 39. So you can see The index value 30 to 39 values has been displayed to you, and you can view, you can analyze the data. You can see here skin thickness at a 33 index are 0. Again, it is a missing value. 36, you can see 36. Again, it is a missing values. Okay, so these all missing values has to be analyzed again and again. Okay, so now we'll see in this instances, the pregnancies, glucose, what is called as instances. In these instances, whether the null values are there or not. Null means missing values are there or not. So I wanted to say you one thing. Even it is 0, but still it is counted as a value. Obviously, it is a 0, but it's a value, right? So if we execute this one, you can find is null. How many values are there in this? Look here, all it comes are a false. No, false means there is no null values. There is no null values. But this is what? It's not a null values. It's a invalid values. We cannot say it's a null values. It's a invalid values. So it is showing that there is a false, false, false everywhere, right? And what we do, we write another called is null and dot sum. It sums all the instances and it gives you how many nulls are there. 0 in a pregnancy level. Glucose level, again it is 0. Blood pressure level, again it is 0. Thickness, again 0. Why it says 0? Because we have given the false value. It's not a null value, right? If it is a missing value, it will be written here as a true. Because I have given here as a 0 values, that's why it is counting as a values. Now what we'll do, we'll print the columns. How many columns are there in this? Columns means all these instances. These instances are called as a columns. So you use a command called as a df dot columns. If you execute it, you can find that the output. So below you can see out. Out means it's the output. In index, you have these many indexes, and the data types are object type, right? Along with the outcomes, you can count it. All these instances are printed over here. Okay. Now, for each and every instances, I want to know some more details of that. So some more details information I want. So if you use it info, and through this info, you will get lot many information about all these instances. You can see here, this is in an index from index 0 to 767 indexes are there. Total 9 columns are there. These are the information you are getting of your data. So whatever the data you have, it doesn't matter that I'm using diabetic. You may use for any kind of data, but you are going to use the same code. So info gives you the information about each instances, that what is all about. The pregnancies, how many pregnancies values are there? 768. How many glucose? 768 data are there, and not null. In these, no values are null. That is what it has given here. No null. No null means there is no null values. And what is the data type? The data types are integer. Data types are integer of a 64-bit microcontroller, 64-bit. If we talk about BMI also has a 768 values. Values means 768% values, and no null values. And these data are the float values. So just let me check it whether the BMI is really it's a float values. Yes, the BMI is in float values. See, here is a BMI, and you can see 36.0, 31.6, 24.8, 90, 19.9. Yes, it's a floating value. So that's what it is giving you, a float value. Diabetic pedigree function is also having a same. So likewise, you can get information about all the instances. In just last column, you can see this output. How many types are there in this? So 2 rows are for a float and 7 rows are for an integer. So this is what exactly the information gives you. So you can see only a very small code, but it's giving you a lot of information. So if you have a millions of data, even a fraction of second, it gives you complete details about your data sets, what information a instances has, and how much space it occupies. It takes 54.1 KB space. Who will take? My data sets. Okay. Now, so another code is about describe. So what is all about describe? The describes gives you that 100% data are how much, 25% data are how much, and 25%, 50% data. What is the mean value? What is the median values? All those. It's a small code, but it gives. Now I'm going to press Shift plus Enter. So it gives you the complete values. How many counts are there for each and every instances? 768 instances are there. So this is what is called as a data analysis that we have to do. And mean, it has calculated mean of all the 768 values in a fraction of second. It has calculated. So this is what a magic of using Python in machine learning. It has calculated mean value. So it is used, the mean value is used for a scaling. When we are scaling our data sets, this mean value is used. When we are standardization and normalization, we are using this one. Okay. And the standardization value, what is the standard value of this 3 point? This one mean value we have calculated. This is a minimum value. Minimum value means among those data sets in a pregnancies, what is the minimum value? So 0. How many values are 25%? So 1. How many values has how many 50% value has a 3? So 50%. How many 75%? 6 value has. Maximum 70 has. So this is what your data analysis for each and every instances you can use by using describe object, describe methods. Now you can transpose it. Transpose means you can see it's written in your instances are written in a rows. So if you use a capital T, this is going to be transposed. I'm going to execute it. So look here, the pregnancies, glucose, all those has comes into columns, and your counts, mean, standard, mean, 20%, 50%, 70% maximum values, it has come into rows. So this is what we call as a transpose. Might you have studied transpose matrix in somewhere in mathematics. Okay, next is, this is the one which we are going to it's going to be very important for us. How many null values are there in this? So I'm going to use a head. I want to print 10 values. So it says that the 10 values are printed, and it says that there is no null values. But I said null values are definitely, it's not there, but invalid are there. What values? Invalid values. So I'll print it, this one. How many null values? So it says no null values are there. So what I'll do, I will do some replacement. And what is that replacement? Wherever 0 values are there, we'll use it. Wherever in this data sets 0. See, look here, insulin, Look here, a person having skin thickness 0. So this 0 value I'm going to replace with NaN value, not a null. NaN ka means it's a not a null value. So what code I'm going to run? I'm going to use this one, import numpy. As I said, it's a numerical analysis. And what I'm going to do the analysis, I'm just importing this numpy libraries. You can use this numpy libraries on a top of this also, or you can use along with the code also. Here I have used along with the code. So numpy is a library and np is an object or instances, you can say. You can execute it. And what I have done it, I have copied this df. I have df is what? Df is a, we have saved our, we have transferred our, you can say here in PD. This is our data sets which I have assigned into df. That, so now all the data sets df has. So I'll take a copy of that and assign into another variable called df underscore copy. So I have taken a copy of df using this command, using copy command, and deep equals to, it's a dependent variable equals to 2. So that we have to make it as a true. True means it is going to copy to that df underscore copy. Once the df underscore copy has been copied, now I will use a list. I'll make a list. How I have used here as a list in a Python. We are using array in C language, and in Python we are using list as a array. It working exactly like an array. So here I have used a list in a square bracket. The same way I'm using a list here. I'm going to use a list. So and all the instances I'm writing into single quotes. So glucose, blood pressure, skin thickness, and these I'm going to assign. In this, I'm going to assign what? I'm going to assign a NaN values. So wherever 0 are there, wherever 0 are there, just replace those 0 values into NaN. That is what here, why the variable has been given here? Because if a glucose has somewhere 0 value, that value also will be replaced. If a blood pressure has a 0 value, that will be replaced. If a skin thickness have a 0 values, that is going to be replaced with a NaN. So that's why I have used all the instances here. How many instances are used? 1, 2, 3, 4, and 5 only instances are used. Why not outcomes? The outcomes it is not used because we don't want to change that value NaN. I don't want to change by NaN. Why it has not? Because that output is fixed. If a person has this value, then it is a 1. 1 means has a diabetic. 0 means doesn't have a diabetic. So I don't want to change those values. So if you after see before replacing what value is coming here, it is coming 0 0 0 0 0 everywhere. Once you replace it, and how we have replaced it? Just with a simple code, nothing hard and fast code in machine learning using Python. Just I used replace. What you have to replace? 0 you have to replace, and using what you are going to using what you have to replace, using NaN. And why we have used NP? Because it is predefined under numerical analysis. Numerical analysis means here numpy. Okay, this is a numpy. So that's why an NP is a instances we have created. That's why we have written here as a np.nan. So this is going to be executed, and my code has replaced the 0 with the nan. So to check whether it has really replaced, so again the same code I will run it here. The df.in is null.sum. The same code, if I run it here, execute it. So you can see the pregnancies are 0, means there is no zeros into this, but the glucose had 5 0 values, and blood pressure has 35 0 values. Skin thickness has a 227 0 values. Before replacing, you are seeing it's a 0. My dear participants, my dear friends, make sure your data has to be analyzed. If you don't analyze, and if you give the same data to the training, while you giving your same data without data preparation, without seeing your data, then the model will not be generated correctly. Model will not be generated correctly. Model will not design a correct model. Algorithm will not work fine. That's why we should always check for whether the data is correct or not, whether it is prepared or not. If it is not prepared, we have made to prepare. How we have to make just for this analysis? We have to do it. Okay. Now we have seen that there are 5 values were 0, and the 35 values were zeros in blood pressure. Likewise, we can see diabetic pedigree function, there is no zeros. Age, there is no 0. Outcomes are no zeros, and all the values are integer values. So that is what we have seen, the difference before replacing and after replacing. Now, if you see whether the really it has been replaced with a nan value, see, if you go to top and go to the index 0, go to the index 0, and you see the second row, sorry, third row, you could see that the skin thickness is 0, and now this 0 has been replaced with what? Nan value, nan. So now let us check whether it has really replaced with that or not. So if we'll use this one, same df underscore copy dot head. If we execute this, and if you see the second row, really it has been replaced with a nan value. Now the machine learning counts that this has no values, means before it was value, that's why it was coming 0. Now machine learning identifies that, okay, this person have no values, so that value nan has to be replaced with what I will understand next. So I'll take your permission, and we'll start after lunch break. Are you there, sir?
Yeah, yes, sir.
So after 12:30 or 1 o'clock we'll start, sir. 12:30.
1 o'clock we will start, and the link will be the same.
Okay, fine, sir. The link will be same, and 1 o'clock we'll start again.
So all the participants can join with the same link, which they used in the morning.
Thank you, sir. Thank you so much.
Yeah, okay.